Okay, morning, folks. How's everybody? Good, 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 good. Okay, so the plan for today, we're going to go ahead, start by looking at the assignment for sum and difference identities. Then we'll go ahead and get into double angle identities. But because the quiz is tomorrow, let's see how ready we are for the quiz. One of the papers that you picked up on the way in was a blank sheet of paper. Okay, I'm going to give you 3 minutes without your notes. I want you to go ahead and write down all 6 of the sum and difference identities. Okay, so I'm going to give you a heads up. You won't be using your notes tomorrow on the quiz. So you got to be able to recall those 6 identities. Okay, let's see how we're doing. Ready, go. There's 6. So there's adding and subtracting for sine, adding and subtracting for cosine, and adding and subtracting for tangent. Okay, 1 minute. Okay, that's 3 minutes. Hopefully this is what we're going to have on your paper, something very similar to it. Remember, there were a few patterns that we wanted to recognize. If you're adding or subtracting angles inside of sine, you keep the operation when you expand it. Adding or subtracting inside of cosine, you change the operation. Sum becomes difference and vice versa. Right? And then tangents are the only ones that have fractional identities. If you're adding in tangent, you keep the addition up top, but it's the denominator where you change that operation. Okay. Right. How did we do? How many folks got all 6? Oh, that is the highest number of hands so far. That's good. Okay. So hopefully this kind of gives you an idea. You've still got tonight. Carve out a little bit of time. Make sure that you know these 6 identities. That is going to make the quiz tomorrow so much easier. Okay. All right, questions. Okay, well, let's go ahead and take a look at the assignment. Now, yesterday, I want to say, yes, I believe we started number 8, but I went ahead and had you try to finish this. Okay, now the thing is, every class yesterday came up with different angles for this number 8 right here. So, can somebody let me borrow their paper real quick? Okay, Vanessa, you were here yesterday, right? Oh, that's fine. I just need to know the starting point. So it looks like yesterday we had a -1. Once we went ahead, found our 2 angles, we used the identity, substituted in. Looks like we have a -1 minus the square root of 3 over. And is that, was it 1 plus root 3 on the bottom? Okay. I was just looking here. I didn't know what that was. So it's this one.
I think so.
Okay. So -1 is 1 plus square root of 3. So is that correct? So it's -1 plus. Okay. So this is where we left everybody off yesterday. Yeah. Ooh, maybe. I know we passed those out last Wednesday. Oh, what would that have been? The 29th. No. Did you find it? Cool, cool, cool. All right, so let's make sure we're all on the same page. This is what we should have for number 8 right now. Okay, so that is going to be tangent of a -11 pi over 12. Good. Now, this one, it makes your life a little easier. We don't have any fractions to worry about, but I do have to rationalize the denominator. Because it's a binomial, I've got to use the denominator's conjugate. What is that? Remember, they're groups that are of the form a plus b, a minus b. So what's the conjugate to 1 plus root 3? 1 minus root 3. There we go. So I got to multiply both the numerator and the denominator by that conjugate. See, I'm multiplying by a version of 1, so I can rewrite the expression, but I'm not changing its value. Okay, so now I've got to FOIL the numerator and denominator. So let's see here. -1 times 1, -1. That would give me a plus square root of 3 plus square root of 3, and then looks like a minus 3. So there's my first outside, inside, last. I just FOILed those two together. Now, here's the thing about conjugates. You can go through the entire FOIL process, but if you realize they're conjugates, you only have to multiply the first and the last terms. The outside and the inside products will always be opposites if you're working with conjugates. So in this case here, the first is 1 times 1, and then the last would be square root of 3 times a negative root 3, so that would be a -3. Okay. And then we'll go ahead and combine our like terms here. Looks like I've got a -4 plus a 2 root 3 over a -2. And the -4 and 2 can simplify with that denominator, so I'm going to break it apart. So this will be a -4 over -2 plus a 2 root 3 over -2. So it looks like I should be getting 2 minus the square root of 3. Okay. There we go. Yes. Yes, do you have your badge? Oh, actually, somebody asked me first. Oh, she already went. Okay, when she gets back. Yes. For a short week, it's kind of weird. Okay. So how many people were able to finish up and get to that binomial? Okay. Do we have any questions on that? All right, now remember, you will have a question like number 8 on the quiz tomorrow. It'll be a tangent of a radian measure. Okay. So why don't we go ahead and practice that algebra again? Okay. Let's look at number 7. Okay, so if I flip it over and take a look at number 7. Now, this one is in degrees. That's okay. Remember, if it's in radians and you're having a little bit of trouble with that, am I okay with you changing it to degrees? Yes, I'm okay with that. I would encourage you work with the radians because that's all you're going to find on your AP exam. Okay, but so doesn't matter if I add or subtract. I just need 2 angles that will combine to give me 165. $30 and 135. Okay. So tangent of 30 degrees plus 135 degrees. Okay. All right. Now, because order is important, 30 is first, so that's got to be my A. That means that 135 is my B. So we're choosing to use the sum identity for tangent. Okay, so let's fill in what we know. The numerator is going to be a tangent of 30 degrees plus, remember we keep the same operation, tangent of 135 divided by, now what happens after the 1? This is where we flip the sign. So we started with a sum, now it's a difference, and I'm going to multiply the 2 together. Tangent of 30 degrees times tangent of 135. Now, we do need to know what each of these are going to equal. We need tangent of 30 and tangent of 135. Okay, so let me go ahead and write these over to the side here. Tangent of 30 degrees, tangent of 135. Now, for one of these, if it's 45 or a multiple of 45, remember that's where the 2 legs are always the same. They're going to be the root 2 over 2. You only have to be careful about what quadrant you're in. 135 degrees is in what quadrant? It's in second quadrant. Y is positive, X is negative. So tangent of 135 should be -1. Okay. Now, let's say you're having a little trouble figuring out, where I got that. Remember, you can go ahead and draw the picture. So here is the 135 degree angle. I'm going to use that to create a right triangle. The reference angle is 45. Okay. So remember, just as I said, each leg is the square root of 2 over 2. But in the second quadrant, X is negative. Remember, what's tangent's ratio? It wants Y divided by X. So I'm going to take the Y value, square root of 2 over 2, divided by X, the negative root 2 over 2. See, I'm dividing a value by its opposite. That's where I got the -1 from. Okay. It's just a way of hopefully making the problem go a little faster. But if you have to draw it, that is perfectly fine. Okay, no issues. Now for the 30 degrees, I'll go ahead and draw it out. All right, let's see what we got here. So 30 degrees. Okay. I'm going to use that to create a right triangle. Hypotenuse is 1. So what was across from 30 again? I forget. Okay, that was 1/2. Across from 60? Square root of 3 over 2. Okay, so we're going to do the same thing. I want the Y value divided by the X value. So 1/2 divided by the square root of 3 over 2. So again, this is where the algebra kicks in. We're dividing by a fraction, so we multiply by the reciprocal. So this is going to give me a 1/2 times 2 over the square root of 3. Okay, looks like my 2's are going to cancel. I get a 1 over the square root of 3, and I have to what? Rationalize. So what is tangent of 30? Root 3 over 3. Is everybody okay with what I've done so far? We chose our 2 angles. Okay, we applied those to the identity. We've evaluated the parts. This is where we're now going to be at the algebra that we were doing on number 8. Okay, so everywhere I have a tangent of 30, I'm going to replace that with root 3 over 3. And tangent of 135, I'm plugging in a -1. Okay, so let's see what this gives me. So tangent of 30, that is a root 3 over 3. And then I'm going to add tangent of 135. So we're adding a negative, so I'm just going to go ahead and say minus 1 over. Then I got 1 minus. Well, if I multiply these two together, I got a negative root 3 over 3. So because I'm going to be subtracting a negative, I'm just going to go ahead and say plus root 3 over 3. Okay, everybody's okay so far? Now, this one, I'm actually glad we worked it this way. This one had an extra step that number 8 didn't because of the angles we chose. This one has fractions. So we're going to want to get rid of those fractions before we start what we just did a moment ago. Because both denominators are 3, let's just go ahead and multiply by 3 over 3. See, that's still multiplying by 1, right? But when I distribute, okay, 3 times that quotient, the 3's are going to cancel, so there's square root of 3 minus 3. Okay, what would the bottom be? There you go. 3 plus the square root of 3. See, now we're exactly where we were yesterday. Okay, so now we just need to go ahead and rationalize this by using, what was that word again? The conjugate. Okay. What would be the conjugate of 3 plus root 3? 3 minus root 3. Okay. So how about I go ahead, let me give you another minute. Let's see if you can get to the final answer. For this one here, you should be getting negative 2 plus the square root of 3 as your final answer. So let's see if you can go from this to that binomial. Okay, remember, don't let this intimidate you. It's just good old algebra. Okay, so you may not be done, and that's okay. Let me see if I can go ahead and catch up. Okay, so if I start to multiply first, 3 root 3 outside, minus 3 inside, minus 9, and then finally last, so that would be a plus 3 root 3. Okay, are these looking familiar? Okay. Denominators, we know they're conjugates, so I only have to worry about the first and the last. So that's going to give me a 9 minus a 3. Okay. Up top, I got a negative 12 plus 6 root 3. That's a 3 right there. Over 6. And I can break this apart to simplify. So negative 12 over 6 plus 6 root 3 over 6. That is how I got that negative 2 root 3 or plus root 3. Okay, how many people were able to get there? Okay, nice. Nice. Okay, so remember, you'll have a tangent problem on that quiz tomorrow. Okay, fantastic. Is there anything else we wanted to look at? Okay, was anybody ready to turn in the assignment, or were we hanging on to it? Sounds good too. Okay. Well, let's go ahead and put this to the side. Go ahead and pull out that paper that's got the double angle identities on there. Okay, let me go ahead and start yours. Okay. Whoops. All right, get that set back up. That is not what I want to get off. Please get off my screen. I do not want to stare at Trump. Ah, get off. There you go. There we go. All right. Okay, so double angle identities. All right, so there's some good news. This is the last set of identities that you've got to memorize. Okay, because after this, the half angle identities, the power reducing, none of those are on the AP exam, so we are not going to be looking at those. This is going to be a really short lesson. In fact, tomorrow I do plan on starting solving trigonometric equations after our quiz. Okay, so there's 5 more. First up, sine of 2 theta. So it makes sense why we're calling them what we do. If you're doubling or multiplying your variable by 2, double angle identities, sine of 2 theta equals 2 sine of theta cosine of theta. Okay. Tangent of 2 theta is once again going to be a fractional value. 2 tangent of theta divided by 1 minus tangent squared. And I saved cosine of 2 theta for the end because it's the most unique. It has 3 equivalent identities that you can use. Okay. Cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. All of those equal cosine of 2 theta, and it does not matter which one you use. Okay, it will still get you to the answer you're looking for. Okay, well, let's look at a couple of these problems. Number 1, cosine of theta is 8/17, and theta is between 3 pi over 2 and 2 pi. We want to find sine of 2 theta. Okay, well, for each of these, we're having to work in a particular quadrant. What quadrant do you think we're in right now? So theta is between 3 pi over 2, which is right here, and 2 pi. So what quadrant is bounded by those axes right there? 4. So this is telling me that we're in quadrant 4. So that means I'm going to have a triangle right here. Okay. Now, because they went ahead and gave me the value of cosine, I already know a couple of side lengths here. Remember, cosine is x over r. So I know this upper leg is 8. I know the hypotenuse is 17. Now we need to go ahead and figure out what the other leg is. Now this is a Pythagorean triple, but I will use the Pythagorean theorem if we have to. It is 15. This is an 8, 15, 17. Now, while it's 15, remember, because we're in quadrant 4, that would have to be a negative 15. Now, because I'm recording, I'm going to go ahead and run through, at least on this one, the Pythagorean theorem to make sure that everybody's okay with that. Let's say this is A, this is B, and this is C. Of course, we know A squared plus B squared equals C squared. Okay, so 8 squared plus B squared is equal to 17 squared. Well, we know 8 squared is 64 plus 17 squared. 299, a little high. 89, there we go. Okay, 289. Sorry, I misheard the first time. 17 times 17, 289. Now, if I subtract the 2, 289 minus 64, that is a 225. When I take the square root, that's where I get the 15. Okay? So see, this isn't anything that we haven't seen before. Okay, we can still fill in side lengths. We can find the remaining side by the Pythagorean theorem. Okay. Now, what we're wanting to find on this problem is sine of 2 theta. So if you think about these identities as formulas, it makes it go a lot easier. Sine of 2 theta equals 2 times sine of theta times cosine of theta. Now, see, we already have cosine of theta. That was given to me. But I need to go ahead and use my figure to determine what sine of theta is. Then I can actually do the algebra. All right, well, let's see here. Sine of theta. Well, I'm looking at my picture over here. What's the y divided by the r? Negative 15 over 17. So see, now that I know the two parts, I can substitute those in. I can get my answer. That's all there is to it. There's no trick. Okay. So let's see. Now, because we're multiplying by fractions, I'm going to go ahead and make this 2 over 1 times sine is a negative 15/17 times cosine. We are given that as an 8/17. See, now all I got to do is multiply those together, and we're good. Okay. Now, the bottom part, we already saw that. What was 17 times 17 again? That was 289. So let's say 2 times negative 15. So negative 30. What's a negative 30 times 8? Negative 240. Now, it's always a good idea to stop and see if it will simplify, but this one does not, because you had several prime numbers as part of your calculation. So that would be sine of 2 theta. Any questions? All right, well, let's try number 2. Okay, so number 2, it says sine of theta is a negative 1/3, and theta is between pi and 3 pi over 2. Okay, so what quadrant is that? That's quadrant 3. Yeah. So here's pi, here's 3 pi over 2. So this is quadrant 3. So I'm going to draw a triangle connected perpendicular to the x-axis. So everybody's okay on how I'm choosing what quadrant? Okay. Now, giving me sine, they're giving me the y value and the radius. So I know this height has to be negative 1, radius of 3, just like we've done before. Nothing new. Can anybody tell me what that other leg is? There you go. Negative 2 square root of 2. Would anybody like me to go through Pythagorean theorem? Buddy? Okay. Now, we're looking for tangent of 2 theta, so let's go ahead and write out the identity. Tangent of 2 theta. So I know that's 2 tangent of theta divided by 1 minus tangent squared of theta. It's just that easy. If I can remember that, you can absolutely remember that. Easy. Okay. Now, in order to find this, all I need is tangent of theta. So I'm looking over here at my picture. Let's see what we got here. So what's the y value? Negative 1. I'm going to divide it by the x, the negative 2 root 2. Well, the two negatives are going to cancel, but it looks like I do have to rationalize it. Anybody tell me what should I be getting for tangent of theta? Ooh, very close. Ooh, a little bit further away. Root 2 over 4. Everybody okay where that 4 came from? Anybody need me to elaborate? Okay. So for this identity here, all I need is tangent. We just found it. So now I just substitute in. Okay. This is where we're going to do a little more algebra. So up top, I'm going to have 2 times the square root of 2 over 4. And then we're going to divide that by 1 minus tangent squared. So a square root of 2, square root of 2 over 4 squared. Everybody okay what I'm doing? Anybody lost? Well, let's see. If I double square root of 2 over 4, the 2 and the 4 will cancel, or simplify, I should say. So that's going to give me a square root of 2 over 2 divided by, so let's see, 1 minus, so square root of 2 squared, that will give me 2. Over 4 squared, 16, so 2/16. I'm subtracting 1/8. 2/16, all I did was simplify. So my common denominator would have to be 8. So I'm going to rewrite 1 as 8/8 because that's still 1, right? So square root of 2 over 2. How many 8s do I have? 7 8s. Now, we multiply by the reciprocal. We should have our answer. So let's see here. Square root of 2 over 2 times 8/7. Okay, the 8/2 can simplify. So somebody tell me, what is tangent of 2 theta? Okay. Oh, too many people are talking at once. I can't hear. 4 square root of 2 over 7. That's it. Anybody having a hard time? Now, it's just like before, you want to go ahead and commit these remaining 5 to memory. I probably wouldn't start tonight because they're not on the quiz tomorrow. Okay, but you do want to focus on the sum of different identities. Okay. All right, we got one more problem, and then we are done because we will not be moving on with the half-angle identities. Maybe at one point AP or College Board will change that. I'm actually hoping at some point College Board incorporates vectors into the curriculum because they're incredibly important, but that's just me talking out loud. All right, let's take a look at number 3. Tangent of theta is a negative root 7 over 5, and theta is between pi over 2 and pi. So what quadrant am I in now? We're in 2. Okay, so this is quadrant 2. Okay, so I'm going to go ahead and draw my triangle here. Okay. I always forget, what's tangents ratio? Okay, y over x. So I know that this would be the square root of 7. This would be negative 5. Okay. So let's start here. Take a few seconds. Find me the simplified version of that hypotenuse. Okay. Use the Pythagorean theorem on this. And we're out of here at 4 after. Oh, we got plenty of time. Plenty of time. Okay. We should be getting 4 square roots of 2. It'll let me run through it. I really got to recalibrate this thing. Let's do this. 4 square root of 2. Okay. So it should be 4 square root of 2. How many folks got that? Fantastic. Would anybody like me to run through the Pythagorean theorem? Okay. Now, we're trying to find cosine of 2 theta, but this was the unusual one. There were 3 different versions. And as I said before, it does not matter which one we choose. Now, if we choose the top one, we'll need to know both cosine and sine. But for the other 2, we only have to know one of them. So let's go ahead and count down from the top. Let's say 1, 2, 3. Which one would you like to use? 2? Let's use 2. 1 minus 2 sine squared. Okay. Now, this is interesting. If you want to use another one, I would encourage you to do it because, again, what's going to happen? You should be getting the same answer. So we're going to use 1 minus 2 sine squared. Okay, so 1 minus 2 sine squared of theta. So the only thing I need here is sine of theta. So I'm looking at my picture over here. What would sine of theta be? What's the y over r? Square root of 7 over 4 root 2. Okay. So would everybody agree? Question. Do I have to rationalize? In this case, I don't have to, because when I plug it in, what's going to take care of that radical for me? The square. But if I go ahead and rationalize, it's not going to change anything. Okay? So what would you folks like me to do? I'll leave it, or I can rationalize. Leave it? Okay. So I'm going to have 1 minus 2. I'm going to plug in square root of 7 over 4 root 2 squared. So take about 30 seconds. See if you can get to the final answer. Okay. Use those algebra students. Everybody ready, or we need a little more longer? Okay. Here is what you should be getting. 9/16. How'd we do? Okay, let's run through it. So 1 minus, let's put the 2 over 1. Okay, so the square root of 7 squared, that's just 7. 4 squared is going to give me a 16 times square root of 2 squared is just another 2. So it looks like I'm getting a 7/32. Okay. And then I can simplify here, 2 and 16. Okay. So it looks like I have a 1 minus 7/16. So we'll do just like we did before, common denominator, 16/16 minus 7/16. There we go. Question. Anybody lost? Anybody having a hard time? Okay. All right. And we're not going to move on, so that's it. I did give you, I wouldn't even call it an assignment. If you wanted to practice a little more with the double angle identities, great. I've already got the key posted, but I am not going to be quizzing you or anything on double angle identities. You got the sum and difference identities tomorrow. I want to move on with the trig equations. Okay, but you still need to know these 5 just in case they do show up on the AP exam. It is very possible. Okay. All right. Other than that, we are done. Let me go ahead and erase all this. And we got about 7-8 minutes left.